Hello, welcome to Ziel classes. My name is Archusmita and I am your maths faculty. So today we are going to learn about fractions, which is a very important topic and a very interesting topic. Say we apply or we use fractions in our daily life. So as we discuss and as we go through the topic, we are going to see how we use fractions in our daily life. So first we need to know what a fraction is. Okay. Okay, very good. So our topic for today is fractions. So now what does fractions mean? The word fraction means a part of a whole. So fraction means a part of a whole. Now don't confuse this whole with HOLE. It is WHOLE. This whole means something like a gram something. We will take examples to understand what this whole actually means. Now let us say you take a circle. Okay. So this is a circle. And I'm dividing the circle into 4 parts. Okay. So I'm dividing the circle into 4 parts. And here's my first part, the second part, the third part, and the fourth part. So these 4 parts together make the whole circle. Yes or no? It makes the whole circle. So each part, this 1, 2, 3 parts, the 4 parts that we made, this each part represents our fraction. And this whole 4 parts, these 4 parts together, they make the whole circle, which is this circle that we have here. So you see, by definition, we say fraction means a part of a whole. So you see the parts over here, 1, 2, 3, and 4. Take any part. I can take this part, I can take this part, it doesn't matter. But you take any part. So these parts are a part of the whole circle. So each part is a fraction. Okay. Now, we are representing this in a drawing form. What if I want to write the fraction using numbers, that is using the language of maths? How do we do that? So our next topic would be how to represent a fraction. Okay, so representing the fraction is our topic. Representing the fractions. Now, we represent fractions using 2 numbers. There is an upper number or the top number, and there is a lower number or bottom number, and a line in between. This is a very general idea on how to represent the fractions. So let us see how can we use this general idea to a more specific idea. Again, we are taking the circle and I'm dividing into parts. Now, make a note of a very important thing about while I'm dividing it into parts is that the parts should be equal. The parts should be equal. See, we cannot take fractions or we cannot take out fractions of unequal parts. Okay, it has to be in equal parts to represent the whole thing into a fractional form. Now, how many parts I have divided into? I have divided the parts into the whole circle into 4 parts. Now, according to the general formula, which is the upper number by the lower number, this lower number over here always represents, the lower number represents the total number of parts. Represents the total number of parts. And the upper number, this represents the parts taken or the parts left with us. So we will understand what the term means, parts taken or parts left. So let's take the example of this circle. So how many parts are there? There are 4 parts together. So if I'm about to write this in a fraction, we draw a line. So how many numbers are there? There are 4 parts are there. So 1, 2, 3, 4. So the bottom part will be 4. Yes or no? Now, how many parts we have now? Like at this moment, how many parts do I have with myself or with myself? So I see I have 1 part, 2 part, 3 part, 4 parts. So the upper number goes 4. So I have 4 parts out of the 4 parts of the circle. So that means I have the whole circle in me. Yes or no? Now, what if you take away 1 part of this circle? Like you omit or you erase that part of the circle. Now, the question arises, what fraction of the circle am I left with? So how will I take that out? So again, how many parts initially did we have? We had 4 parts. So the bottom number goes 4. Now to represent the fraction of the circle that I'm left with, we will count the number of parts that are left after omitting the part which is missing. So how many parts am I left with? 1 part, 2 part. So I'm left with 1, 2, and 3 parts. So how many parts are left with? 3 parts. So the upper number goes 3. So the fraction of the circle that I'm left with is 3 by 4, or 3/4 of the circle is left with me. Okay. And if I ask you, okay, how much or what fraction has been taken away, so what will be your answer? You will count the total numbers of parts. How many numbers are there? There are 4 parts. How many parts have you taken? You have taken 1 part. So the fraction will be 1 by 4 or 1/4. So 1/4 of the circle is taken away and 3/4 of the circle is left with me. Now, question may arise, is it applicable only for circles? No, not at all. It can be for anything. Fractions can be for anything. Let us say our next example, which is I'm taking a rectangle. Consider this is a rectangle. I'm dividing it into 1, 2, 3, 4, and 5 parts. I'm dividing into 5 parts and I decide to shade the 1 part, 2 part. And thus I'm shading this one also. So the question will be, how many or what fraction of this rectangle is shaded? So what we will do, first we will count the total number of parts. So how many parts are there? So the rectangle is divided into 1, 2, 3, 4, and 5. So we see the total number of parts is 5. And how many are shaded? 1, 2, and 3. 3 parts of the rectangle are shaded. So 3 parts are shaded. And if I write this in fraction form, so the fraction of shaded area will be 3 by 5. Yes or no? Understood? Because there are 5 parts together, so the bottom number is 5, and 3 parts are shaded, so the upper number is 3. Now, there's a specific term or specific name given to this upper and lower numbers. We just don't say it's upper and lower number. There's a specific name for it. The upper number is called a numerator and the lower number is called a denominator. Okay, so fraction is represented by 2 numbers, one upper number which is called the numerator and one lower number which is called the denominator. Clear? Okay. Now when we are talking about parts of a whole, Does that mean that whole means only one object? No, not at all. Whole means one object, or it can be a group of objects or anything. So our next example will show that. Okay. Let's say you have 5 cats, you have 2 dogs, and 1 hamster. So together, what do they make? Together, these are your pets. Okay. So the whole here means the group of animals over here or the pets that you have. So you see, it's not a single object. There are 5 cats, 2 dogs, 1 hamster. So they all together they make a whole of pets. So now, if I want to take out the fraction of the cats present, or the fraction of dogs, or the fraction of the hamster, what will I write? For the cats, it will be 5 by. So what are the total numbers of animals we have? 5 plus 2, 7, and 1 hamster, that 8. So fraction of cats is 5 by 8. The fraction of dogs is 2 by 8. And the fraction of hamster is 1 by 8. So you see, we can use fractions while we are dealing with one object or a group of objects. So this is a very real life example, right? Like you're taking out the fraction of your pets. Also similarly, like maybe you're dividing a pizza and you decide to eat 2 parts, like divide a pizza into 6 parts. You eat 2 parts. So what is the fraction of pizza that you have eaten? It will be 2 by 6, right? So that is the 2/6 of the pizza you have eaten, and you're left with 4/6 of the pizza. Clear? So what did we learn today? Let's revise. So we learned that what are fractions? So fractions basically means a part of a whole. Fraction means a part of a whole. Now this whole can be a single object or group of objects. Fraction has 2 numbers, the numerator and the denominator. The denominator representing the total number of parts and numerator representing the parts that you're left with or the parts that have been taken. It depends according to the situation. And fraction can be applied not just for one sort of thing like a circle or rectangle or what. It can be applied for various things. It can be applied in all situations. So I hope this helped you a lot, and I hope you understood fractions. We will discuss more about fractions in the next class. That's all for today. Thank you.